Hello everyone and welcome to Virtual SAS Global Forum 2020. My name is Jim Kuell and today I'm going to be talking about diagnosing the most common SAS Viya performance problems. I am a software performance engineer in the SAS Performance Lab in Compute Services R&D. I work very closely with SAS technical support, our customers and hardware partners on a daily basis. I wear many hats in my job, but everything that I do revolves around trying to maximize performance for customers, both internally and externally. Today I'm going to be talking through our methodology for diagnosing performance problems, which consists of two main parts, gathering information and then analyzing that information. Then I'm going to talk a bit about the most common causes of performance problems that we see at customer sites. A quick note about this presentation. Whenever I say Viya throughout the presentation, I'm going to be referencing Viya 3.x. There's a lot of content to cover in the next 20 minutes, so apologies in advance for talking quickly. So in the Performance Lab, we understand that diagnosing performance problems can be extremely difficult and time-consuming. We've spent many years doing so, and throughout that time, we have developed a methodology and we've refined it quite a bit that helps us really get to the bottom and get to the root cause of these performance issues as quickly as possible. We use it daily, both internally and externally with customers, and use it quite a bit to help with SAS technical support tracks when our customers are having performance issues. Our performance process does surface multiple causes of performance issues quite often. It's very important that whenever you are trying to fix these issues, you only make one change at a time. And I'm going to kind of harp on this a little bit throughout the presentation. So the initial set of information that we're going to gather in this process, we're going to use that as our baseline measurements. And that's what we're going to use to compare future changes and results against to see if we're improving our performance. So after each and every change is made, you're going to want to go back and follow it with another round of testing and information gathering and analysis. And then you compare that to see if you're headed in the right direction or if you've achieved the performance that you're looking for. It's also very important that you document everything that you change along the way. Last thing you want is to see a couple potential causes of a performance issue, and then you make a handful of changes all at once, and then you retest and you see that your performance is actually much worse than it was initially. So you try to revert all those changes, and you end up not being able to remember everything that you did change. You don't want that to happen, so make sure you document everything along the way. So gathering information, it's obviously the most vital step in the process. Here at SAS, we love data, and we try to gather as much data as possible. It's extremely important to understand all the aspects of the environment and the specific performance problem at hand. We gather a bunch of information, and we use that, and we craft it to create a story that we use to eventually lead us back to the root cause of an issue. It's very likely that no one piece of info is going to lead us to the root cause of an issue. So what we do is we take it and we correlate it all together to create that story. Once we have the information and we are looking at it, we usually start by looking for telltale signs of the most common causes of performance problems, because 9 out of 10 times that's going to be the causes. So as we work with those, we tend to know, we see little flags of what what is in that information that leads us to that diagnosis. So I'll talk about that a little bit more in a couple slides. Also, the situations at customer sites, some are more complex than others, so some may require additional information gathering, but what I highlight in the next couple slides is going to be enough to get to the bottom of most of these. The information that we gather is also going to be very similar with SAS Viya as to what we gathered with SAS 9, but how we analyze it is going to be extremely different. With SAS Viya, they're between all the microservices, your application layers, your physical and virtual infrastructures, your file systems. There are many more moving parts. So our analysis process has to stay very fluid. The first and most important thing that we gather is the problem definition. Finding the origin of a problem is impossible without first clearly understanding what the problem is. We need to make sure that the definition isn't just what the user's perception of what's happening is, but what's actually occurring on the systems. A lot of times we'll have tech support tracks that are opened where a customer says, my system's running slow, or it's not running as fast as I want it to, and that really doesn't tell us anything about what's going on. So we really need to know what is happening on the system. Is there a single table that all the users are trying to operate on, or are all the users trying to load and process separate tables? Is there a job that's running slower now than it was previously? When does the issue happen, and how often does it happen? This is all vital to getting to the bottom of what's going on. And in that, we need to know what the ideal outcome is. What level of performance is going to make the user happy? Are there any SLAs that need to be accounted for? Next is the application definition. Different applications have varying impacts on the performance of the system. So we put together a full mapping of all the applications that interact with the problematic systems, not just the SAS Viya applications. In this, you need to make sure that you identify the specific SAS Viya applications that are having the problems, because that really changes how we go about looking at all the information, whether it be visual analytics or visual statistics or something else. Also, what interface is being used to start the SAS jobs in question or run the SAS jobs? Are they being run via batch or via SAS Studio or Enterprise Guide? Next, we work to create a full infrastructure definition. Many performance problems can be traced back to issues within the infrastructure, whether they're hardware or software-based, and that includes the server and network information, the operating system level tunings, and your I/O subsystems. There are tons of parts that make up the infrastructure, and any one of those can ultimately be the culprit of a performance problem. So it's really important that we understand every aspect of the system. We've written a tool that's called the REL Gather Information Script. I'll discuss this more in a couple slides. But this helps give us a more detailed look at the operating system level info, and it's really a great complement to the information that's provided by the customer. So a couple things that we look for in the 3 bullets here. For the server and network information, we typically look at the make and the model of the system and what the instance type is if it's in the cloud. Are there any virtualization software that's being used? We look at the CPUs and the memory, and the network connection, the speed and type of that. For the operating system, we typically dive into the operating system version and the tunings quite a bit. We also look at the file systems that are being used for your permanent SAS data files, as well as the temporary SAS data files, which is going to be your SAS work and your CAS disk-cache. And also the source data location and type, that has a big factor as well, whether it's SAS data files or an external database or Hadoop or something else. And also your I/O subsystem information. We look at all the the cards and the ports and any connections being used and the bandwidth of those. SAS logs are typically where we begin our investigation. We need logs from the jobs that are surfacing the performance issues. Those are vital to the process. These contain metrics and session options that really help us narrow down the cause of an issue. If it's possible to also get SAS logs from when the jobs are not experiencing the performance issues, then that's just an added bonus. We also want logs from the SAS applications that are experiencing performance issues as well. And tech support can work with customers to give them specific instructions on how to turn on debug logging for these applications. And they can actually also provide a few other helpful settings for the SAS job logs as well. We usually can't tell what the bottleneck is from the SAS log alone. However, it does give us a much better indication of what the issue is, as well as the time frame for when it occurred. So we can then take that information and we overlay it with the other tools and information that we've gathered, and that really helps us narrow down what to look for and when exactly to look for it. There's a ton of moving parts in SAS Viya, like I was saying, so analyzing the logs is much more complex than it was with SAS 9. With SAS 9, we would always see a couple red flags in the logs, and we typically know exactly what to look for after that. This, like I was saying, is much more fluid. It's much more complex, so we ask our customers to collect those logs and submit them to SAS tech support, and then my team will work with tech support to analyze those and ultimately get to the bottom of the issues at hand. The next couple slides are going to be a couple tools that we like to gather, tech support likes to gather as well. The first of which is the rel gather information script, which I briefly touched on a couple slides ago. This is a standalone script. It was written by us here at SAS, and it's free. It does not require a SAS installation. We ask that this is run on all problematic systems. What it does is it gathers and packages relevant OS level information. So we can then take that output and we can look through it and look at how different things are set up, how different things are tuned. We can see if our best practices are being followed and stuff like that. And it really helps us create that infrastructure definition. Another tool is called the SAS Viya Perf tool. This is another standalone tool that was written by us. What this does is it tests the available throughput of the network between the CAS controller and the CAS worker nodes. It also tests the throughput of the SAS data and CAS disk cache file systems. This is in the final stage of development, so it's not quite released yet, but we will post on the SAS Community's administration page whenever it's released, so keep an eye out there for when that is finished. Next is IBM's Admin Script. This is my team's hardware monitor of choice. It's free and you can download it from the web. What it does is it runs a bunch of existing tools behind the scenes and it compiles all that data into a flat text file. We then use what's called the Admin Analyzer to process all that data, and that turns it into a graphical tab-separated Excel document, which makes it much easier to look at. This needs to be running on the problematic system the entire time that the SAS job in question is running, and it's really important to have both of these running from the same time period so we can correlate those results. Sometimes customers will send us an Nmon and a SAS log from two separate time periods on the same system, and that does not help us at all. Another really helpful tool is called Gridmon. This is included with SAS Viya. This is a CAS administration monitoring utility, and what it does is it lets us really dive into the activity on the CAS nodes in a deployment. We can see what is happening, and you can stream it live or you can record it to a file. So we ask customers to record it to a file, and they can send that to us, and we can pull that up and play it back and look at what exactly is happening on all those nodes at the time that the performance problem is happening. And the final two tools are TK Grid Perf and SAS Peak. These are both also included with SAS Viya. TK Grid Perf, we use it to really isolate network issues between the CAS server nodes, and SAS Peak is a Viya metric collection utility. It's awesome, and that runs on all the machines in a Viya deployment. So I'm going to go through some of the most common causes of our performance problems that we see at customer sites. Like I said earlier, the infrastructure is almost always the cause of performance problems with SAS Viya. It's made up of tons of different parts and pieces, and any one of those can ultimately be the cause of the problem. So, while every situation varies in complexity, and it may be something outside of this list, this list of stuff is going to account for the vast majority of issues. The most common and one of the most easily correctable is an insufficient network bandwidth. There's a large amount of communication between the different SAS Viya nodes, and there's also quite often a large amount of data transfer between these nodes as well. Because of that, we strongly recommend a minimum of a 10 gigabit NIC for the inter-node communication. Next is the physical location. It's extremely important that every component and resource of a SAS Viya infrastructure is physically located as close together as possible. This includes everything from your source data files to the storage to systems to your authentication, and you always want those located on the same subnet. I've seen customers put source data in one public cloud, their compute resources in another public cloud, and their authentication back on premises, and that just really kills their performance. We've seen serious performance hits anytime a WAN comes into play. Next is going to be your bandwidth to external storage. SAS Viya has very heavy I/O throughput needs, and we've unfortunately seen this unaccounted for in quite a few architectures that we've reviewed. Our minimum recommendation is 100 megabytes per second per physical core for permanent SAS data files, and 150 megabytes per second per physical core for temporary SAS data files. Also, when using network attached storage, we've seen a lot of success come out of using a separate NIC for the storage than what is used for the internode communication. Next is memory. As I'm sure you know, SAS Viya is an in-memory analytics engine, and it uses memory map files. So in order for it to operate optimally, it needs to stay within the bounds of virtual memory. In order to make that happen, you need to make sure that the CAS controller and workers have enough memory for that to happen. So as a general starting point, we typically recommend that memory is 2 times the size of total incoming data. Again, this is just a starting point, so you need to make sure you monitor the systems and are ready to expand it from here if that ends up not being enough. The amount of memory needed can vary greatly from site to site, so it's really important that you do a detailed workload analysis before setting up your infrastructure and to make sure that your memory capacity planning is done correctly. Next is the SAS disk cache. This is incredibly efficient file system. It serves as both an extension of memory maps as well as a backing store for your replicated data. It's extremely fast when it's set up correctly, but you need to keep in mind it's still not going to be as fast as the processing speed of in-memory. SAS disk cache can only perform as fast as the devices that it resides on, so it's really important that you have enough RAM to keep the processing in memory. While SAS disk cache is also going to be used when you have enough RAM, the amount that it's used is going to depend on the specific application and what is being done by that application. The default location of SAS disk cache is /temp, and we find that that is quite often the cause of performance issues with this. We usually recommend to change this location for 2 reasons. One, if /temp fills up, then the operating system can't run correctly and everything on that system stops, which is bad. And 2, /temp is typically not very performant. So we like it to be moved to a file system that can meet our minimum recommendation of 150 megabytes per second per physical core. I get a lot of questions about how big SAS disk cache should be, and we usually recommend starting with about 1.5 to 2 times the size of memory. The same as with memory, it's really important that you monitor your systems and you're prepared to expand the size of SAS disk cache if you find that more space is needed. And lastly is virtualization. This is an extremely common practice and can actually be very performant if it's set up correctly. The main thing to remember is SAS does not perform well when it's thinly provisioned, especially when it's in a virtualized server farm with shared everything. SAS really likes dedicated resources. This is extremely important to remember if you're moving to a cloud-based environment. A lot of times you can end up using shared resources and not even know it. So it's extremely important that you have dedicated resources. And with virtualized environments, we have found a lot of the performance issues with these can be traced back to the underlying hardware not being set up and tuned for performance, and that really needs to be. Another quick note to keep in mind of virtualization is you want to prevent NUMA from coming into play. And we usually see this happen when the virtual CPUs span multiple physical sockets. So what now? Well, once you've identified the cause or the causes of the slowdowns in your environment, you need to determine what you want to change to correct these issues or improve them. Like I said earlier, it's really important that you only make one change at a time. Each change should be followed by an additional round of testing and information gathering and analysis. So if you have multiple potential causes of issues in your environment, you're going to want to make several iterations until your desired performance is eventually achieved. Once those changes have been implemented, it's extremely, extremely important to continuously monitor the environment. Data sizes, application usage, your number of users, number of jobs, these all change over time, often increasing by quite a lot. So proactively monitoring the usage patterns allows you to be prepared when additional resources or upgrades are needed. And majority of the time, it'll end up prevent you having to go through this entire process in the first place. Thank you all for listening. My paper on this topic is available on the SAS Global Forum website, and my contact information is listed here if anyone has any questions.